Hello, welcome to Logical Clock's webinar on the topic of Feature Store for Databricks. I would like to remember you that you received the recording of this webinar by email within 24 hours, and there will be a question and answer section after the webinar. I will now pass it on to our CEO and presenter of today, Dr. Jim Dowling.
Hi, thanks, Natalia. So today we're going to go through the feature store, the Hopsworks Feature Store, and we're going to look at it in the context of Databricks. But we're going to go through it step by step. So I'll introduce what is a feature store, and we'll go a little bit through some slides to present some background information about it for those of you who aren't familiar with feature stores. And then we'll move into a demo later on. So you may not have heard of us. We are called Logical Clocks. We're based out of Stockholm and Silicon Valley. I'm the CEO, and this is some of our management team. So the platform that we'll be talking about is called Hopsworks. It's a platform for data-intensive AI that includes a feature store, but the feature store is available as a standalone product for use in Databricks and SageMaker. We've won a lot of awards for our technology, and we come from a research background. So one of the reasons you might be here is because you're considering using a feature store. And the typical journey that people take when they want to use a feature store is that they start out doing feature engineering with ad hoc scripts, jobs. You know, maybe you manage them in GitHub and you don't really tend to reuse them. And you'd like to move towards sharing your feature engineering jobs. And then once you've gotten to a stage where you can share these feature engineering jobs, you might consider, well, maybe we should have a central place in our enterprise to manage all of our features for machine learning, to share them between engineering and data science. And we're going to talk a bit about the difference between offline and online feature store. So the offline feature store is really for storing large amounts of features for both batch and for training of models. And the online feature store is for storing features to be used by real-time online applications that need to actually get features in real time to build what we call feature vectors with which they can make the predictions. What I won't cover too much today is the next stage after you have a feature store, which is how do you pull this all together in MLOps infrastructure? So how do you integrate your feature store with model repository, jobs, serving, provenance, and so on? Okay, so you may have heard about feature stores. Our feature store is called Hopsworks. It's the world's first open source feature store. It's the only enterprise feature store that's out there currently. But pretty much every hyperscale AI company has a feature store. And Uber were the first ones out there with Michelangelo. Other well-known ones are Zipline by Airbnb, Gojek have done one called Feast, which is available on GCP, and there's other ones by Facebook, Netflix, and so on. So if you want to find some more, there's this nice reference, featurestore.org, where you can find an extensive list of all the feature stores that people have talked about publicly. So I'm going to start at the beginning. What is a feature? So if you have a data engineering background, you may think it's a column in a table. In fact, that's not the full story. It may be an example of a feature, but typically features are taking that raw data from the back end, from our databases, from our data lakes, but we typically want to do something with it. We want to turn it into numerical data. We don't feed strings directly into machine learning models. Maybe it's an image, maybe we're going to have a pixel, maybe it's a word. But typically features are often things that help us predict something. They're a measurable property of some phenomena. And they're useful in terms of being able to have a signal that your model can easily pick up on and train on to make better predictions. So things like aggregations, windows, and often very complex representations such as embeddings, language embeddings, word embeddings, graph embeddings. These are the type of features that we find give a lot of value in areas such as natural language processing, in terms like fraud and financial models. So if that's what a feature is, well, where does our data come from? In the enterprise setting, we typically have our data in data lakes, databases, data marts, data warehouses, file systems. And what we need to do is take that data and turn it into the numerical format on the right-hand side that data scientists are used to. So they work with numerical data in arrays. If you have a bar chart in your database, you can't feed that in directly. You might turn it into numerical data using something called one-hot encoding. So this is the gap between data engineering on the left and data science on the right. And I'll give you a quick example of code for those of you who like to see things in code. If I have, for example, if we look at this particular, let me go back here. So if we look at this particular example here, we have a column called features, and this is the original data coming from our backend system. And you might be happy with it and say, it's numerical data, I can feed it in directly. But we can see that there's some large numbers and small numbers. And typically machine learning models prefer to have a more compact representation. We want to shift these values to between 0 and 1, or between minus 0.5 and plus 0.5. So this is called normalization of in this case, a particular feature. And there's lots of other typical ways in which you'll do feature engineering. Some of them will require coding, some of them will not require so much coding, but typically you're going to write programs to do this. There's no magic wand you can wave to just take your data and turn it into features. So the other problem that you have with feature engineering is you might have a very popular model, and a common example of a popular model is BERT. You can see it below. So this guy BERT is it's a pre-trained model for natural language processing. It's made huge waves in the deep learning domain. And maybe many different departments in your company say, well, we want to use BERT. So each of them are going to implement their own feature engine pipelines to take their raw text data and convert it into features that the pre-trained BERT model will use. So they're going to duplicate that work. So you'd like, obviously, to share it. Another problem that the feature store will address is the problem of that we have we're going to do our feature engineering when we're training models, but we're also going to do feature engineering when we're using the models to make predictions. That's what we call inferencing. So if we see here, we have training up here and we have inference down here. And the inference is the application that's going to make the predictions. Maybe it's written in Java or Python, but the training is typically done in Python using frameworks like scikit-learn, TensorFlow, and PyTorch. And what you want to make sure is that the features, these things that are being inputted into your models, the data, that they're consistent, that you don't implement the feature once in your online application and another time in your training application. The two can diverge. You'd like to just implement them once. So that's basically what the feature store will help us do. Feature store will be a central point where we can compute features at one individual place. So we can compute our features here and we can ingest them into the feature store. And then when we need to use those features for training, we can get those features and turn them into training and test data. And then when we need to use those features for model serving, well, we can get those features at low latency to our online applications to make the predictions. Okay, so that's some of the motivation for the feature store. Our particular feature store, the Hopsworks Feature Store, is built on three main concepts, and I'm going to introduce them one by one. So the first two concepts are the notion of features themselves. You can think of these as the columns in your databases, if you will. And these features typically will be computed together in groups. So if, for example, I have a backend database and I'm getting data related to customers, well, maybe I go to that one database, I compute that customer data, and then I update it once a day in the feature store. Maybe I want session data from my shopping carts, and I'll update that more frequently. It'll go to a different production database, and maybe it'll do it every 15 minutes or 10 minutes. So these things are called feature groups, and what a feature group is, it's basically a set of features that are computed together. Now, I have an example here. This example is the Titanic passenger list. It's a well-known problem in data science. And we have, you can see, 4 different features for the Titanic passenger list data set. Now, this is a thought experiment, so bear with me. Imagine we have, for example, a historian who discovers a new data set and they ingest it into the feature store. And this contains information about the amount of money the passengers in the Titanic had in their bank accounts. So it's stored in a different feature group. And now we can see we have 6 different features, 2 of which are the same, the name that we can see there. So a data scientist comes along to our feature store and says, I would like to do an experiment. I think that if I join together the balance and then the other features in the Titanic passenger list data set, I can make better predictions about whether passengers survived or not. And the reason I can do that is because I think this passenger bank account feature, the balance, I think that that will be predictive for whether a passenger bribed to get on a lifeboat. So the data scientist has his or her hypothesis and goes ahead, and we can see that they then have a training test data set that they create. And this will be created, and it needs to be made available and stored somewhere. So you do is the data scientist will do is say, well, which framework am I going to work with? If I work with TensorFlow, I'd like the data in TF record file format. If I'm working with scikit-learn, CSV, NPY files, if I'm working with PyTorch, and so on. And then they need to decide where to store it. So if we're working with Databricks, we might decide we'll store it in an S3 bucket. Everything that we've seen here are abstractions. The features, the feature groups, and the training and test data sets, they're all versioned. Okay, we move on. So we have our three abstractions: features, feature groups, and training data sets. What the data engineers will do will be register feature groups and ingest data into the feature store. So the abstraction that we provide for this is the data frame. Excuse me. So you can have either a Spark data frame or a Pandas data frame. And typically what you would do is you would use Spark, PySpark, or Scala Spark, or Python and Pandas to read data from a backend system. So maybe the backend system is Redshift, maybe it's S3, or maybe it's some other production database, or data warehouse, or data lake. You read up the data, and then you do your feature engineering in your programming language of choice, typically Python, but sometimes Scala. We support both Scala and Python APIs, and Java as well. So once you've done your feature engineering here, so you do your feature engineering, you basically need to then ingest this data frame. This is our data frame here, Titanic_TF, and we give a name to our feature group. So that data frame will have a number of columns or features, and it will end up in the feature store. And you can also, of course, update feature groups with new data. So if you have an existing feature group and you want to update that data, you can call update on that feature group. The data scientists will typically want to look at the available features in your feature store. And if you take a feature store like Uber's Michelangelo, they claim they have over 20,000 features. We have some customers with many hundreds of features. Well, data scientists can often find the features that they want to use to build their prediction models in the feature store as it is. Sometimes they'll need to add new ones, and as you have more and more features in your feature store, the utility of that feature store will increase. So what we can see here in this example is how does the data scientist create a training data set by joining together these different features. And if we continue on the Titanic data set problem that we talked about earlier, what we can see here is that on the first line of code, we join together these four different features and we get back a data frame. So there's a query planner here that we implement internally, which will find a common join key between our feature groups. And then with this data frame, we can output the data in the file format of choice to a connector. So we want to store it in S3, we can use a connector, or we can store it to the Hopsworks file system itself. So in this case, this small piece of code here will be used to join different features in the feature store together and output our training test data that we can use then to train models. So internally, what's happening in our feature store is that we have a storage layer which is made up of two main databases. One called Apache Hive, which is a columnar database. It scales to store very large volumes of data, petabytes. And then we have an online low latency in-memory database called MySQL Cluster. And this is used to store the online feature store data so that the online applications over here can get their feature vectors in very low latency. And this provides a JDBC API, so your apps can be written in whatever language they like, as long as they have a JDBC connector. So the data scientists will be responsible for typically ingesting these features into the feature store, managing access control to the feature store, looking at statistics of features, metadata over features. And then on the other side, the data scientists will discover features, create training data sets, and also be able to analyze historical values of features. So you can go back in time with, if you're using a framework called Hoodie, and I won't talk about it too much today, but Hoodie is another way of storing feature groups that allows you to query data as it looked like in the past. You can say, show me the values of the features between the year 2017 and 2018, or show me the value of this individual feature at this particular point in time. So it's quite similar to Delta Lake in Databricks, if you're familiar with that, but it's an Apache project. Okay, so how does this feature store used in a pipeline? How is it used in the context of Databricks? So the feature store, our feature store here, you can see it is this thing here. And you have your data in your backend data warehouse. It might be Athena, it might be Redshift or whatever data warehouse you're using, you may be using Kafka or some other stream log-based storage engine. And you may have a data lake like S3 at the back end. And you have a lot of your data from these different sources, and you want to read up that data, and you'd like to then ingest those as features into either the online or the offline feature store, or both. So we have this feature engineering jobs that we're going to write, and these jobs will run at their own cadence. So depending on the features that you're now currently ingesting, they may need to run every day or every hour, or it could be even a streaming job that runs the whole time and is ingesting constantly into the online feature store. So you can run that in Databricks. You can also run it on our platform. But if you run it on Databricks, then you get the advantage of using their platform. And once the features are in the feature store, you then want data scientists to go ahead in their own cadence, run their own experiments. And typically what they'll do is they'll select features that they want to use to create training and test data, and they'll output that data to S3 buckets, and then they train models, and then they validate their models. And this is an iterative process. And all of this can happen, of course, within Databricks. You manage your experiments until you're happy enough that your models are good enough to go to production. So your models themselves can be used in batch prediction applications or in online applications. They're typically the two classes of applications that use models that are trained. So the online application is interesting because what it can do is it can go directly to the online feature store to get its feature vectors. And once it's built up the feature vectors, it can send it to a model that's typically being served over the network. So TensorFlow serving server, and you want that model to be monitored as well. So this is how the feature store fits into pipelines. We typically have the data engineering or feature engineering pipeline here, and then we have the training pipeline here. And they're typically two separate types of pipelines. Now, if we put this in the context of building ML applications, what does this mean? Well, one way we look at it is we say the data engineer is there to produce features. And they produce features by writing data pipelines that feed data into the feature store. So the feature store then becomes a repository for features, and the data scientist will typically go to the feature store using features. They'll train models. So they have a complex process of doing experimentation, searching for good hyperparameters, validating models, evaluating their models. And then finally, when the models become available, they can be used in batch applications, or which is pretty straightforward, or they can be used in online applications. So in this case, if you have an online application, you want to make your model available via an API, and this is where an ML engineer comes in. So the ML engineer will take the models from the model repository, make them available via this API here, the Model Inference API that you will expose for your model, and typically models can be served in SageMaker or in Kubernetes. Our platform supports serving models in Kubernetes. And in our case, what we do is we also log all the predictions that are made to Kafka. So Kafka can come with our platform built in. And when those predictions are logged to Kafka, you can have a Spark streaming job that will model or monitor these models in production. So it's going to ingest all of the predictions that were made through that topic in Kafka. It will then compute windows over those predictions to compute things like descriptive statistics. What is the mean value of a given feature? What was the standard deviation of a feature? What was the min and max values? And we can compare those with the descriptive statistics in the feature store. So we can use that then to do things like look for data drift in your features, and we can do it quite efficiently. So finally, once your app model is available via an API, applications can go ahead and use those APIs. So an app developer will use the model APIs to build intelligent applications. And the only things they need to use is the Model Inference API, but also the features, the online feature store they need to use to get features that they can't compute internally or haven't computed internally, and get those cache features and use them to build feature vectors to make predictions. Okay, a couple of words about the online feature store before we move on to a demo. An online feature store is used by an online application. And as I mentioned already, the online application will want to build a feature vector because things like Windows, for example, if I have a fraud application and I want to know how many transactions a user has executed in the last week or month, well, the application doesn't know that internally. So it can go to our online feature store and ask for the value of that feature for that customer. Or it can look up the credit score for a customer and so on. So that online application will go to the online feature store with the JDBC API in our case. it'll make the query, it'll get back the feature vector, and then the model itself can be either embedded in the application, or more commonly, it'll be served over the network, because then you can decouple the life cycle of the application from the model. The model can be updated frequently and rollbacked and so on, without having to redeploy the application. So in our case, our online model server is based around MySQL cluster, which is called, we call it NDB often. That's the storage engine for MySQL cluster, is called NDB, which stands for Network Database. And so the interesting properties of NDB is that it's extremely low latency. So it's an in-memory database. It supports a MySQL API. But also it's highly available. So you can have it across availability zones. You can deploy NDB across 3 availability zones in a region in AWS. And if one of them crashes, well, it's still available. If 2 of them crash, it's still available, because it's actually synchronously replicated. It's not quorum-based replication. So your online application can use MySQL cluster to build its feature vectors. And then when it's got a feature vector, it sends it to the model, typically over the network. And depending on how many features you need to retrieve, whether you need to join them together or whether it's a simple primary key lookup, that can happen all between 10 and 50, 60, 70 milliseconds between when the application has a request to when it builds its feature vector to when it actually makes the prediction. So that concludes the kind of basic introduction to what is a feature store, and we gave a brief overview of the Hopsworks Feature Store. Some things we didn't cover, which you can cover offline, are things like time travel. We didn't cover in too much detail, data versioning, MLOps. But what we'll do is we'll go through the main concepts of how do we do feature engineering, how do we create training data sets, and then how do we use this platform within the Databricks environment. So I'll skip through this and we'll talk about the agenda for the demo. We're going to have a quick overview of the feature store at Hopsworks. So we have our feature store available now as a managed platform on AWS. And we'll look at how you can access your features and how you can control who can access those features. We look at creating features using Databricks, searching for features, and creating training data sets in S3. Okay, so if you're interested in the platform, it is an open source platform. It's an AGPL-v3 licensed, and the enterprise version of Hopsworks differs in that it supports some enterprise integration. So you can do your model serving and run your notebooks in Jupyter on Kubernetes, and we have support for LDAP, Active Directory, OAuth2, and GitHub in the platform. So if you want to try it out, you can follow it along. You can register now. So Hopsworks AI, as it currently stands, and we'll switch to it now. Okay, so now we're at Hopsworks AI. So this is Hopsworks.ai. If you register for an account here, it will you'll have to authorize Hopsworks to launch a Hopsworks cluster in your AWS account. If you don't have an AWS account, or if your company is too restrictive in allowing you to launch clusters from external platforms, there is a demo instance. You'll be able to try it out. So you'll be able to log in, create an account, and try out the platform. Okay, so I've already logged in earlier. So this is kind of what you see when you logged in. I have a cluster running, and I can run another cluster if I want. This is the cluster that's already running. I can expose some of the services that are available. We have support for backup. And you can stop that cluster and start it if you don't need to use it. So this is the cluster that's running, and I'm just going to log in here. And you can see that this is the landing page. So we have a bunch of tours here. Typically, you would run this feature store tour to get started. I have already run the tour. So this is what I get. I get a project called demo_featurescore_gym and a lot of zeros. I also created another project called the Dev Feature Store. So this abstraction that we have called a project, it's quite unique to Hopsworks. So with a project, you can think of it as like a GitHub repo. It's a place where you have data, you have programs, and you have members of that project. And all of the data and programs are private to that project. If you want to share something between these projects, you can do so. So in terms of the feature store, you can think of each project as a database, a feature store database. So you might have a a group database, a company-wide database, we can consider this one to be one. And then we might have a development and a staging one. And you might even give individual developers in small teams their own feature stores. And they can do their development of their features on them. And when they're happy with them, then they can migrate those features to the group database or group feature store if your process allows that. So I can just show briefly how that security aspect works. So we have something called a feature store here. You can see there's a bunch of services on the left. We're going to look mostly at the feature store. This particular feature store has 27 features and 7 feature groups. And then we have this thing called cross-project features. So if I'm in a development feature store, I can still access the group-wide feature store. So this is actually the group-wide one. So you can see there's only one feature store there. And if we go to my development feature store, which is this one here, I actually have not added any features in it. But I have added the main group feature store. So I can still write code to join features from the group-wide feature store with my development one to create training data sets. So this is a nice way for enabling MLOps, all in a single cluster without having to run separate clusters. We have customers who are doing this in production, their development and production on the same actual cluster, because there is a cluster manager behind this platform. So I'm going to go in to look at our feature store in here, in this particular project. We can see that there's a number of feature groups here. We can see that are the concepts that we talked about, the individual features. We can see here we have a lot of individual features, and it keeps going. And those features are grouped into these, is it 7 different feature groups? Yeah, 7 feature groups. So if we take any given feature group here, so we have one called teams features, so it's features of football teams. If we click on view statistics, when you ingest a feature group, a set of features, you can automatically compute statistics so that data scientists can then quickly go in and look at descriptive statistics for the features. We've got team position, and we can see counts, means, standard deviation, min, max, and so on. And we have another feature called team budget, another one called team ID. Probably it makes more sense to look at the schema for that particular, if we look at the schema for that particular feature group, we can see that there's these 3 features, team budget, team ID, and team position, and they're all numerical features. There was a job that was used to compute this. We can get a quick preview of the data if we want, so we can see that briefly. So this is all useful things. And then there's some descriptive data, and you can attach arbitrary metadata as well as JSON objects to these feature groups. So we can look in briefly that we talked about before, the feature correlations. We can look at some of our cluster analysis that was computed automatically in distributions of different feature values. And data scientists typically will do this to see what features are available, to understand the data and the distribution of the data for given features before they then decide to create training data sets. Now, you can create a training data set from the user interface. I showed you some pseudocode before, and I'll show you some real code later. But just to give you an idea how easy it is to create a training data set, you can pick a bunch of features, like we can pick a couple of features here. And you can add more features, of course, to this shopping cart. And our query planner then will try and find a common join key. So it found actually 3 join keys, potential join keys. And you basically, you can either take the one suggested by the feature store, or you can specify your own one. And you can have multi-part join keys, and they can be quite complex. So we'll call this one just hello, this training data set. And then you can pick your file format. So it can be TF records. Oops, we go down here. We can pick one called Pedistorm, which, if you haven't heard of it, is a very interesting new Parquet-based file format that Uber have developed. So you can decide to store this then in S3 or in HopsFS. And if you store it in S3, you have to define something called a connector. And the connector points to a bucket. So that tells you the bucket where your training data will end up in. So we can then go ahead and create this. And what it will do is it will create a Spark job, and we give the resources to it. So we give this a Spark job here in our platform, and you can run that Spark job. So these are our jobs. We're now in this jobs UI here, but this is not Databricks. So this would run a Spark job on our platform, on the Hopsworks platform. So we'll look at how to do that on Databricks in a moment. I'll just briefly show you the storage connectors. So here you can add connectors, and I have added one already for S3, so that you basically can click through to give it word connector to S3. So typically, yeah, you'd enter the name of your S3 bucket, and then if you have an IAM role that will give you access to S3 bucket, you don't need to enter the access key and secret key. It'll actually just, it'll have permissions to access it already. Okay, so the one last point before we move on, we do have support for data validation in here, which is kind of nice. So one of the issues with Python is that Python doesn't have any good APIs or libraries for doing data validation right now. So we provide a user interface, a way of adding rules for validating feature groups. So you can basically say, well, for this particular feature group, we have a min size of 1 and a maximum size of 1,000. And if it's outside that range, I want an error rather than a warning. So you can add a bunch of these rules together. I want this particular feature, the average attendance, to be, to be within this range, and so on. And basically this will create a feature validation job again on our platform, and then you can run that job against that feature group to validate the data and put it into from an external Airflow cluster, or from within our platform. We also have Airflow. You can then make a pipeline that will ingest the data and validate it without having to learn a framework, to learn to write Scala code, for example, in DQ, which is a library that's used for data validation. Okay, so this is a brief overview to the UI and what it looks like inside of Hopsworks. So if we move outside of Hopsworks and we go to Databricks, so this is Databricks. I had it up earlier on. Okay, so I'm just going to show you before I do that. If you Google Hops examples, you can follow along with these. With this, okay. Doesn't seem to like my URL here. Okay, let me just try one more time. If you Google for hops examples, you'll actually find it. Okay, it doesn't seem to like doing that. I'm in full screen mode. Maybe that's partly one of the reasons. So this is my Databricks workspace. So I have a notebook, and this notebook, I think it's called Feature Store Quick Start in Databricks. It's available on GitHub. It's your homework to actually go ahead and find it. Let's close this. I think we do that. Okay, that's not what we wanted to do, but we'll go back again. Okay, so now we're back in here. So it's getting an execution context. Maybe we'll try and just detach and reattach. Okay, so this is Databricks, and I'll just click run all actually, and then I can walk through this and we can talk through the commands. So this notebook tells you how to get started with the feature store from within Databricks. One of the things you need to do to get started is you'll need to import a library called hops. So that means that if you have a cluster in Databricks, and this is our cluster in Databricks here, I've called one called Gym Webinar, you'll need to add this library called hops. So this is the library here, hops. We're pinning it to version 1.2, which is the current version of the Hopsworks cluster that I'm running. And when you install a library in Databricks, you need to restart that cluster. But there's a couple of other things we need to do to the cluster that I'll get to in a second, not just installing the library. Because what we're going to do is we're going to run Spark from within the Databricks cluster, and it's going to read and write directly to the Hopsworks cluster. So we can see it's actually started going here. So the second cell here, we can see here, if I zoom in a little bit, it says feature store.setup Databricks. So what it's going to do is it's going to return some instructions to me. It says you need to add this init script. So I need to add this init script to my cluster. And I also need to add this Spark config information. So this is enabling your Spark cluster to get our certificates that you need to use to connect to the Hopsworks cluster, and also the location of our Hive, which is our offline feature store. And there's another, if you need the online feature store, you can connect to that as well. So you have to follow these instructions. You have to copy this. I'll just show you briefly what you have to do for that. You have to go into your cluster and you have to edit your cluster. And then in the advanced options, you have to paste that in here to the Spark config. You might want to change this to the local private DNS name if you to make it work better. And then you need to add this script here. So that's basically the main configurations you need to do. You can see I picked the 2.4 ML cluster in Databricks, and that includes TensorFlow libraries. So if I'm going to write out data's TF records, then those libraries will be automatically included there. Okay, so this next line here, feature store, after feature store setup, this next cell, it says feature store.connect. It's going to connect to our Hopsworks cluster, and it's going to connect to the name of the project. That this was the demo one that I created. And this Hopsworks cluster should be in the same region, and not just in the same region, but also in the same subnetwork. And I'll show you in a second how we do that. And the reason we want to do that is because we want this Spark job in Databricks to be able to connect directly to our Hopsworks cluster to read and write data. And to do that, then we need to ensure connectivity between them. You can do that by VPC peering, but it's more complicated. So what's going to happen in the implementation of this is when I've started this notebook, this Spark cluster running on this notebook running on this Spark cluster, the IAM role that I started this cluster with, and typically you will start a cluster with an IAM role. I can show you briefly the one I started this one with. You can see I started with one called Jim Databricks down here. You can see that. So that IAM role will be authorized to read a secret key, an API key to Hopsworks. And the place it's going to read it in is in the AWS managed secrets. You can see it's called a secrets manager. So it's the AWS managed secret service. You can also use the parameter service in AWS. You can even use a file. You can put the API key in a file if you want, which if you're using Azure is the current way we support on Azure. But basically what's going to happen here is it's going to use the IAM role to connect to the secrets manager, get the API key down, and now it's securely connecting via secure sockets to the Hopsworks cluster. And from here in, we're now authenticated and we've authorized ourselves against that individual project. And we're now able to read and write using Spark to the cluster. Now, the next, if I keep going through the cells here, we can see that I have a bucket, and my bucket is called Jim Oregon, and I mounted it. Now, this cell failed because I'd already mounted this bucket before, and that's expected behavior. So let's go and look at the bucket. This is our bucket, Jim Oregon. You can see there's nothing in it. But I was actually running the command, so maybe something has arrived at this stage. Nope. So let's go back, and we'll go through the next cell. So the next cell we have down here are, this is a well-known, so you see it says command skip, so I'm going to actually have to run them again, because it's when it failed here, it actually stopped. So let's go down here, and that's going to run this. So this particular cell is a well-known problem in data science. You have a data set with houses for sale and the size of those houses, the square footage. So what you're trying to do is feed in new data about new houses within in a certain area and predict how much that house would sell for. So let's run through these commands here. So what this particular example is doing is it's generating some data for the houses for sale. It's going to then save it. I think maybe I had saved this already, but it's saving it to my S3 bucket, in fact. So I think I actually deleted that, so we'll have a look back in a second when it runs. You can see the Spark job is running here. It's just showing you some of the data in our houses for sale. And now we're saving it to our S3 bucket. So in fact, that should be, if we keep going down, and I'll just go through some of them, we'll see that data in our S3 bucket in a second. I'm just going to display the mount point here. So yeah, we can see in here we should have, in our S3 bucket, we should have some data arrived in here. And we have our houses for sale, parquet file, and the houses sold. So these are our two data sets. So we're going to use the train data with the house for sale, and then we're going to make predictions about how much they were sold for. So let's keep going through some of these cells. Again, this is available in GitHub in the Hops Examples, Notebooks, Feature Store, Databricks folder. So these particular cells are just doing standard feature engineering. You can see that we're calculating the average number of bidders, the average that a house is sold for. This is classical feature engineering. You're computing aggregates. And let's keep going down here. So this is the key line. So at this point, we've created a data frame called house sold features data frame, and we're going to register it, both of them, the houses sold and the houses for sale, with the Hopsworks Feature Store. So in this case, we've set the descriptive statistics to be false, so it's not going to compute those and enter them. but you can set them to true and it will compute those statistics and enter them. So it says it's created that successfully, that feature group. So, and now we're creating the other one. So let's go and have a look back in Hopsworks to see if we can see that feature group. So let's refresh here. So yeah, we can see now that our two new feature groups have arrived in Hopsworks, houses sold and houses for sale. You can go and inspect them, and we can see that there should be the version that they're created on. And if we go back to Databricks, that's typically where the data engineering will finish. You'll ingest feature groups, and there's more examples for importing them and updating the data in the feature group, not just when you create it, but when you actually update the data. So at this point, a data scientist can typically come along and decide, I want to get a bunch of features from those two different feature groups, join them together, and create some training data. And I would like that training data to be in the TF records file format, because I'm going to train the model in TensorFlow. And the sync I'm going to use is the Gym-Oregon S3 connection bucket. That's it defined in our feature store. So we can see that here. If we go back to our storage connectors, it's going to use this particular S3 bucket. So if we run this, what it will do is the query planner in Hopsworks will take these features from the two different feature groups. It'll find a common join key, it'll join them together, and we'll get this features data frame, and then it will generate that training data, as you can see here, in the file format of choice. So if we go to S3 and refresh back here, what we'll see is that we have our training data set is here. So now a data scientist in Databricks who's using not just Python, but R or any other language can work with this training data set to train a model. So this is the path that they will use to the training data set, and we can see that there's a Parquet file in here with the success file telling us that it was written successfully. Okay, so that's the walkthrough of the notebook for how to get started with the feature store in Databricks. Let's have a little look at Hopsworks AI, and you can get an idea for how to get started. So I mentioned already that if we want to launch a Hopsworks cluster, it should be able to connect directly to Databricks. So let's have a look at how we do that. So to look at that, we're first going to look at the cluster that we started in Databricks. So this cluster, we can see in the advanced options, it's running in US West 2C. So we need to know the availability zone that this cluster is running in, because we want to start our Hopsworks cluster in the same zone. So what I'm going to do is I'm going to go up here and click on Run a New Instance. So we're going to pick on US Oregon, which is US West 2. You can pick on the size of cluster, number of nodes 1. And if I want my Hopsworks cluster to access buckets in S3, I can give it an IAM role here. Then I need to pick my VPC. So if you give Hopsworks AI the privileges to list the VPCs in your cluster, then it can find the Databricks VPC. So if you have a very restrictive enterprise environment, there is a restricted way of deploying Hopsworks, but you will have to then enter that VPC by hand. So once we've found the VPC for Databricks, we also need to look, and we know it was in US West 2C. So we saw the cluster was running there, and then I can go ahead and deploy this cluster. Yeah, we'll go ahead and just deploy. So this is going to take about 5 minutes. I'm not going to, we can see it's pending. It's going to create the AMI and so on. So we'll let that kind of go ahead and run. So if we go back to Hopsworks itself, and we look in here, the one thing I haven't talked about so far is membership of projects. So how do we do access control? So if I go back to the very home page and we have more than one feature store, development one, and we have a production one, how do I control who has access to it? So Hopsworks will integrate with your own Active Directory if you have it. You can also manage the users yourself. But once your users are in the system, you can see we have this membership tab here. So in this project, you can see it's just an admin. I think there's another user in here, if I'm correct. I couldn't find any user. Okay, I didn't register any of the users. But you can basically add other users in here and give them a role. So the two roles you have here are data owner and data scientist. So you can basically add data engineers and data scientists to the same project. And if you have a data owner role, then you're able to ingest data using the ingestion APIs, but data scientists can only create training data sets. So we've restricted the rights of the different users based on whether your role is data scientist or data owner. So data owner is, in the GDPR sense of the word, an owner of the data responsible for that data. Okay. I think I'm going to, I'm conscious of time, and we're at 45 minutes. We can have a quick look and see how the Hopsworks cluster is going ahead to launch. But you can go ahead and run this. You can see it's just starting up the instance itself. At this point, I've been talking for 45 minutes, so I'm going to pause for questions. And I'm not sure which screen I go to, but I'll see if we have any questions.
Let's open.
I think if we get some infinite screen, if I navigate to the chat here.
It's okay. I'll read the question over, and you can answer. What do you think? Good.
Okay, that sounds good to me. Yeah.
So somebody asked, is Databricks really needed, or is Logical Clocks Feature Store generic?
Yeah, so you don't need to have Databricks, of course. So Hopsworks itself will, you can use it with GPUs, you can use it with Spark, and you can run everything you want in Hopsworks. You can do end-to-end machine learning on Hopsworks or data engineering on Hopsworks. You could also use other, I think someone's breathing on the line, just in case we can get that out. Okay, so you can also use the Hopsworks Feature Store with SageMaker, and it works very well with SageMaker. And you can also use it with, and we have an upcoming webinar on using the Feature Store with SageMaker. You can use it with Kubeflow. So the main points of how you connect, if you're running within Hopsworks, you don't need this connect statement here. If you're running from an external non-Spark cluster like SageMaker, you can connect again using this secrets manager where we register our API key. I can show briefly how we register the API key. It's very straightforward. You go to settings in Hopsworks, and in here you have API keys, and I can just create them here. We'll call it Databricks. The API key might be to run a job, the feature store, and project. This API key that I've created, I can copy it, and then if I go back to Amazon, go to S3, you just go to your secrets manager here. This is all in our documentation, so you don't need to know exactly what's going on here. But basically, I created this existing secret that has the key in it. So you just need to click here to create that. And you can obviously restrict the IAM role that it just reads this particular secret and nothing else. So you can use it from Kubeflow, and you can use it from Azure, and then in those cases you would typically put that API key in a file because you don't have a secrets manager service in those cases. Okay. I don't know if that answers the question.
A little bit muffled, but it was good.
Okay.
I think we have more time for maybe 2 more questions. Is Hopsworks community on-prem deployable?
Yes, actually, in fact, it was developed originally as an on-prem platform, so you can just install it. If you Google Hopsworks installer in our documentation, there is a command line utility that will help you install it in an on-premise cluster. So typically, what you'll need is some, at least if you want to get started just on one machine, we kind of recommend 32 gigabytes of memory to run the whole platform, and maybe up to 50 to 100 gigabytes of storage just to get it started. But we have installations running on petabytes of data. It comes with its file system, this next generation HDFS called HopsFS, and we have a lot of very large installations. In particular, people are using it for scalable deep learning. You can have hundreds of GPUs that are managed and train very large models in that case. And the feature store is then a key data infrastructure component in a end-to-end machine learning platform, in our end-to-end machine learning platform. Yeah.
Does the Databricks cluster and Hops cluster work together? Who runs what part of the work?
Yeah, that's a very good question. So to do feature engineering, so there's two parts that I showed in the slides before, and I'll kind of just go back to one of the slides here. I haven't covered the online feature store, I'm aware, in that much detail. So these are the two parts here that we can see. So we have this feature engineering stage, and this is typically going to be either Spark or in Python. And then we have the model training here, okay? And this again is going to be Python or Spark, typically, or PySpark. So this code, it can run on Databricks, these circles, or it can run on Hopsworks. It's your choice. So we have very large customers we find who are already Databricks customers prefer to keep using Databricks for their Spark computation. And then they use the feature store as the data component in this infrastructure, in this end-to-end pipeline. But then we have customers who use the whole of Hopsworks for the feature engineering and for the training. It's a little bit easier to use Hopsworks by itself, but if you want to use a feature store for Databricks, then of course you can use our one. It's the only one that's available out there right now.
To finish our webinar today, you mentioned the feature stores, they store features and can recreate features as they are available at a specific time. How does this work with data deletion after the date? Mainly think of GDPR.
Yeah, okay. So I didn't go into this in a huge amount of detail. I'll refer to a notebook if you have time here to look. Let's see, I need to actually disable that. There we go. So if we look for, we have a notebook on Hoodie on Hopsworks. So Hoodie, Hopsworks, let's find it in here. Okay, so we have a blog post which will talk about MLOps of the feature store. But if we Google for Hops examples and we get to GitHub, I hope you can see my screen here. We have this notebook section and then the feature store. And then we have one called Hoodie here. So if your feature groups are backed by Hoodie, what that means basically is that any updates you make to your feature groups, any new values you add, or any values that you change, right, that you delete. So if you delete data from your data lake, which you could delete data from these feature groups in very large amounts. If you decide not to clean up all of these will be files, Parquet files that will be stored in your on the file system. In our case, we will store the files in an S3 bucket in your account very soon. Currently, it's storing them on the virtual machines, but within a month, it'll be storing it in your S3 bucket in your AWS account. But these files, as new data comes in, we store a copy of it. Okay, so that's what Hoodie will do. It does something called copy on write. And if you delete data, well, it'll create a new version of this partition without your data in it, but the old delta, the old change between that version and the new one is still there. So you can still go back in time and look up values that maybe have been there. Now, if you, for GDPR reasons, you need to really delete that data, well, then you have something called garbage collection in here. I think it's a collection. So we can find it in here. Compaction, I think is the correct term actually. So then you can run a compaction which will actually delete that data in Hoodie. So I would recommend you to read up a bit more on Hoodie, but just to show you some of the things you can do in Hoodie, you can, in this case, we can say, here we can see that we're appending data to an existing data set, and it'll update older values, and then we can look up values at a particular point in time. So we can see at a given timestamp, we can do time travel. I can say, give me these features where the commit time was this timestamp. So that's a really nice property of Hoodie on Hopsworks. Okay.
We're going to answer all other questions by email shortly. I want to thank you, Jim, and everyone who participated tonight with us. And I also like to let you know that we have 2 upcoming webinars, and you will receive the link to sign up after this one. Thanks, everyone. Have a good night.
Thank you. Thanks, Natalia.